Hello and welcome to this lecture on energy balance. Energy balance occurs when the energy, so the calories that you intake, equal the amount of calories that you expend. Your body weight tends to be stable during energy balance. Now, you can slip into positive or negative energy balance. Positive energy balance is when you gain weight because your energy intake is greater than your expenditure. So you can see the silhouette, she's gotten a little more plump. And that's because on the scale of energy balance, her food intake outweighs that of her exercise. On the bottom part of the screen, you see negative energy balance. This occurs when energy intake is less than energy expenditure. Body weight tends to decrease during negative energy balance. And so what we're going to look at during this lecture is what are the different components of both the energy intake, but more importantly, the energy expenditure side of the equation. Because at this point in the class, you already know about where you get calories from. A little bit about the relationship between hunger, appetite, satiation, and satiety. If you haven't heard those terms, satiation and satiety refer to the feeling of being full. Okay, now our goal is to be full of nourishing foods so we get enough nutrition but not too much, that we feel satisfied but that we don't overdo it or underdo it. So let's start in the upper left-hand portion at step 1, the physiological influences. Okay, what are the things that make us feel hungry? Did you know that actually having an empty stomach causes contractions of your stomach that actually send neurotransmitters to your brain that tell you you're hungry? So if you haven't eaten in a long time, you don't have any food in your stomach, you don't have any nutrients in your small intestine and your bloodstream, and so your digestive system starts to trigger hormones and neural signals that create feelings and sensations of hunger and appetite. So now we move on to step 2, sensory influences. In addition to just physically feeling hungry, there's lots of external things like the smell, the sight, or the taste of foods that may enhance your desire for them. Think about when you're walking through the airport and you smell Cinnabon cinnamon buns. You might not actually be physically hungry, but all of a sudden because of the smell, especially of the fat cooking, and you're walking by it, and you got a bunch of time to kill in the airport, you all of a sudden feel like you need to eat a cinnamon bun. Okay, those are the sensory influences at work that allow you to seek food, start your meal, and then we move into the pink box on the lower right where you keep eating. Because you have cognitive influences. You've got the presence of others or social stimulation. Maybe boredom. You're in the airport. People eat just because they're bored. Okay? Perception of hunger, awareness of fullness. If you're around your favorite foods, okay, or foods with special meanings, you might be more inclined to eat them even if you're not actually hungry. Okay, the time of day. How many times do you find yourself eating lunch just because it's 12 o'clock? People who have work or office jobs do that a lot. They might not actually be hungry. They just eat because it's 12 o'clock. Okay, and then we always have the problem of the abundance of available food. We live in a 24/7 food environment where I'm sure no matter where you're listening to this lecture, with the 99% of you could go and get food within the next 2 minutes if you wanted to. Okay, food is constantly around us, which causes us to eat more. In step 4, we see the onset of satiation, or the end of a meal. Okay, you have post-ingestive influences. After food enters your digestive tract, food in your stomach triggers stretch receptors. Nutrients in your small intestine then elicit nervous and hormonal signals that inform your brain, hey, this person's fed, stop eating. We move on then to step 5, which is satiety. Several hours of other activities have passed since you've been eating, and you've got other post-absorptive influences. After your nutrients have transferred through your stomach and into your small intestine, they get into your blood and signal your brain about their availability of nutrients, how to use them, and that they need to be stored. As your nutrient status dwindles, so does satiety, and eventually you'll develop hunger again, and then you'll move back into the cycle one more time. When we talk about energy balance, though, it's important to differentiate the difference between appetite and hunger. Appetite is defined by your desire to consume specific foods triggered by external cues. For example, the smell of food. You smell that cinnamon bun and the fat cooking, and then you want it. That's your appetite at work. Okay, this works independent of hunger. Hunger is the actual physical desire to consume food that is triggered by internal physiological signals. Okay, that's when you actually physically feel hungry. But you might eat because you physically feel hungry and eat that donut to make you not feel hungry, or you might eat because your appetite tells you to, which is you smell that donut, okay, and all of a sudden you want it. On the energy intake side of the equation, as a brief review, you get calories from the following 4 places: fats, proteins, carbs, and alcohol. Keeping in mind that all excess calories, no matter where they're from, can be stored as fat. Your hormones play a role in how much you eat as well, to some degree. Okay, and the effect of these aren't really entirely known because many of these hormones have only been discovered recently. One of the hormones that helps to regulate appetite and intake is called leptin. Leptin is a hormone produced by your fat cells. Okay, now think about that. Previously, it was thought that fat was an inert substance. It just sat there and made you fat. But we now know that fat is actually metabolically active tissue. Your fat tissue is sometimes referred to as your adipose tissue. And it's constantly secreting hormones, neurotransmitters, including this hormone called leptin. And the role of leptin is to help suppress your appetite. Basically, what's supposed to happen is when you've eaten, leptin should get released to tell your brain, hello, this person's had enough fat, stop eating. When people lose weight, what happens is they tend to lose or see reduced levels of leptin. And their body tends to interpret that as starvation. It's sometimes related to why we see a slowing of the metabolic rate with weight loss. Okay? Leptin levels tend to be correlated with the percent body fat in individuals. And women have higher concentrations than do men. Now, when leptin was first discovered, it was thought, well, this is going to be genius because what we'll do is we'll just find all the people who are leptin deficient and we'll give them leptin hormone, which will suppress their appetite and they won't eat. But the problem is, most overweight people, they're not deficient in leptin, they're just resistant to leptin. Okay, so the leptin that they have doesn't really work that much. Okay, so it appears that overweight and obese people are leptin resistant, and you can't just trick them by giving leptin. So there are all sorts of really cool animal studies that came out once leptin was understood and was first discovered, but they haven't really transferred well into the human space, and leptin hasn't been proven to be this weight loss hormone that scientists originally thought it would have been. Another hormone that plays a role in appetite is ghrelin. Okay, and ghrelin is a hormone that's secreted by your stomach muscles. So leptin's made by your fat tissue, but ghrelin's made by the cells in your stomach, not your tissue, from your cells. I sometimes remember ghrelin, you can think of ghrelin like your stomach is growling. Okay, ghrelin is what makes you feel hungry. Okay, so ghrelin, when it's released, acts on your hypothalamus, which is your hunger center, to stimulate hunger and stimulate food intake. Ghrelin basically works the opposite of leptin. Before you eat, when you're hungry, your ghrelin levels are high, and your ghrelin levels decline after you're done eating. Ghrelin levels tend to be high in people who are lean and low in people who are obese. An interesting application of ghrelin is that some of the associated weight loss that comes with gastric bypass or weight loss surgery is thought to be due to the reduction in ghrelin. The part of the stomach that secretes ghrelin gets bypassed. Okay? And so these people end up feeling less hungry because the parts of their stomach that secrete ghrelin have been bypassed, so they're not in use. Now let's move to the energy expenditure side of the scale. You got energy intake and you know where calories come from, but how do you get rid of calories? There's 3 basic components: the thermic effect of food, physical activity, and your basal metabolism. We'll start with basal metabolism because that counts for the majority of your total energy expenditure. Okay? Total energy expenditure is abbreviated TEE. And somewhere about 65%, somewhere between 50 and 70% of your total energy expenditure is made up of basal metabolism. It's the basic stuff you need to do to keep yourself alive. You actually burn calories doing that. Now further up the scale, you've got physical activity. This is the energy required for movement. And it accounts for anywhere between 15 to 30% of total energy expenditure. Okay, now of course that can vary depending upon whether you exercise more or exercise less. Lastly, and most minutely, I'm not sure, you see the thermic effect of food. Okay, it makes the least contribution to your total energy expenditure. The thermic effect of food, which is sometimes abbreviated TEF, is the energy required to process food. So when you eat food and you're digesting food, it actually burns some calories, okay, about 10% of your total energy expenditure. So you're burning calories by eating calories, if you want to think of it that way. Now, of course, your basal metabolism constitutes the greatest amount of energy expenditure. But the one over which you have the greatest control is physical activity. Okay, you can increase the amount of physical activity you do, thereby increasing the amount of calories you burn. And the cool thing about physical activity is not only do you burn more calories when you're actually exercising more, but every day of physical activity increases your basal metabolism. So if you exercise, let's say earlier today or yesterday, you are burning more calories if you're sitting on your butt listening to the lecture right now than if you hadn't exercised. You burn more calories at rest, meaning your basal metabolism is increased, if you engage in more physical activity. So physical activity not only helps you burn calories while you're doing the activity, it also increases your basal metabolic rate. Basal metabolism, there's a couple of terms that sound similar, so I'll spell them out for you here. Okay, basal metabolism is the energy expended to sustain basic life functions. Okay, so you can breathe, your heart can beat, your nerves can function, your muscles can stay functioning as well. The basal metabolic rate refers to the amount of energy expended per hour. Okay, it's somewhere between 50 to 70% of your total energy expenditure is made up by your basal metabolism. Basal energy expenditure refers to what your basal metabolic rate is over the period of 24 hours. So basically, how many calories did you burn over those 24 hours? That's the BEE. What are the different things that affect your basal metabolic rate? Okay, you hear sometimes people say things that change your metabolism. Okay, as far as your actual metabolic rate as it pertains to weight, one of the few things that changes your metabolism is going through menopause. Okay, when women go through menopause, they lose hormones that previously had supported higher rates of metabolism, and so they end up burning less calories at rest. That's why it's extremely important for menopausal women to exercise regularly so that they don't gain weight by eating the same amount of foods that they used to eat. A couple other things can affect your basal metabolic rate. The greater the percentage of lean body mass you have, the higher your basal metabolic rate is. It takes more fuel to fuel a pound of muscle than it does to fuel a pound of fat. Fat doesn't do a whole bunch, it just sits there. Muscle's constantly working. You burn more calories if you're working on muscle than you're working on fat. Males have a greater percentage lean body mass than do females, so they almost always have higher basal metabolic rates. Your body temp, have you ever heard that phrase, feed a fever and starve a cold? It's because your basal metabolic rate goes up in fever, or whenever you have an increased temperature. Age. There's a reduction of about 2% in your resting energy expenditure for every decade after 30 years. So when you hear people say, oh, I just can't eat like I used to in my 20s, it's because in your 40s and your 50s, you're experiencing a 2% per year decline in your basal metabolic rate. Energy restriction, we know that if you severely restrict your calories, your basal metabolic rate will slow down. It's a huge problem with people who yo-yo diet or have overly restrictive calorie diets. You go down to 600 or 800 calories, yeah, you'll lose some weight right off the bat, but your body immediately starts to think you're starving it and shuts down its basal metabolic rate because it doesn't want to be starved. It needs to conserve energy. Genetics, some people are just predispositioned to having high or low basal metabolic rates. Your endocrine system plays a role. Your thyroid, which controls your metabolism. Hypothyroidism is low thyroid. It leads to a reduction or a sluggishness of your basal metabolic rate. Whereas hyperthyroid is when everything is revved up and your basal metabolic rate increases. Periods of growth have been shown to increase your basal metabolic rate. Okay, so during pregnancy and breastfeeding, those things raise basal metabolic rate. And stress raises your metabolic rate. Not just stress of like mental stress because you have a test coming up, but any sort of stress related to your health condition. If you've gotten a motor vehicle accident or you have a big wound or a burn and your body's working to recover, your basal metabolic rate will be higher than normal. So that's your basal metabolism. Again, that's about 50 to 70% of the energy you expend. Physical activity is about 15 to 30%. And it includes things like your planned and daily activities, walking, doing yard work, work-related activities, fidgeting. Even fidgeting burns calories. You might not have known that. And then something called NEAT, non-exercise activity thermogenesis. This is the energy expended for everything that is not sleeping, eating, or sports like exercise. Okay? So it's kind of like digesting and, if you're fidgeting, keeping your body warm that way. This next slide has a lot of info on it, but it's actually pretty straightforward if you take a second to look at it. Okay, this is an equation called the Harris-Benedict equation. It's another way to help you determine calorie needs. I'll show you this way and then a much easier way next. Okay, this is a validated equation that if you know somebody's height, their weight, and their gender, as well as their activity level and whether or not they're sick, you can calculate how many calories they need, what their basal energy expenditure is. And remember from a couple slides ago, that's basically how many calories do you need a day. If you're a female, that's the first bullet point. Your basal energy expenditure, you take the number 655.1 plus 9.6 times your weight in kilograms plus 1.9 times your height in centimeters minus 4.7 times your age in years. If you want to calculate your weight from pounds to kilograms, divide by 2.2. And if you want to calculate your height in centimeters, multiply your height in inches times 2.54. So your weight in kgs is always less than your weight in pounds, and your height in centimeters is always more than your height in inches. Think about that. People usually want to weigh less than they do and be taller than they are. So when you're converting from pounds and inches to kilograms and centimeters, you go down from pounds to kgs, you go up from inches to centimeters. For males, the equation is 66.5. That's not a typo. Okay, some people think, oh, it's supposed to be 665. It's not. 66.5 plus 13.8 times weight in kgs plus 5.0 times height in centimeters minus 6.8 times age. And you can see that subtracting off the age component means that the older you get, the less calories you get. Once you figure out your BEE in step 2, you multiply that times an activity factor and an injury factor, because being both sick and active nets you more calories. Okay? So you can look online to see what exactly determines a sedentary lifestyle versus low active versus active and very active. But you would multiply your BEE times, let's say you're a low active person, 1.1. And if you're not sick, you don't get an injury factor. If you are sick, things like surgery can be 1 to 1.2, infections 1 to 1.4. That's really something you learn kind of more in a clinical class. Okay, but just keep in mind that being sick increases your injury needs or your calorie needs as well. So if you have both an activity factor and an injury factor, you would multiply BEE times activity factor times injury factor and basically get how many calories you need a day. Or you can do it online. There's a link to a calculator and it's a lot quicker. Another way to do your calorie needs, if you're trying to figure out how many calories you need and you don't want to be bothered by that huge long equation you just saw, is to do what's called the calories per kg method. Okay, this is a rule of thumb for determining how many calories a day you need. And basically the way it goes is that if you want to maintain your weight, multiply your weight in kgs by 25 to 30. If you want to gain weight, you eat more, so multiply your weight in kgs times 30 to 35. If you want to lose weight, multiply your weight times 20 to 25, keeping in mind that 1 kilogram equals 2.2 pounds. Okay, so let's say we've got Barbie. She's 5'9" and she weighs 110 pounds. In the last lecture, we talked about how to determine percent ideal body weight, okay, or what ideal body weight is. So let's start with what's Barbie's ideal body weight. Okay, she's a 5'9" female. Using that Hamway equation, she gets 100 pounds for being 5 foot, and then you add 9 inches times 5 pounds per inch, which is 45. So her ideal body weight would be 145 pounds. If we were asking for a range, we'd usually give her plus or minus 10%. But for the sake of this assignment, let's just leave it and say Barbie's ideal weight's 145. But she only weighs 110 pounds. Okay, there's all sorts of speculation. If you were to actually make a real Barbie, first of all, she's anatomically impossible, but they think she'd be 5'9" and 110. Okay, if she's supposed to weigh 145 and she only weighs 110, that means that she's only at 76% of her ideal body weight. Okay, 110 divided by 145 times 100 is 76. Anytime someone is less than 85% of their ideal body weight, we say that they need to gain weight. Okay, so Barbie's only 76% of her weight. She needs to gain weight. Okay, so to gain weight, we would multiply her weight in kgs times 30 to 35. Okay, so her weight in kgs is just 110 divided by 2.2, which is 50. So I would do 50 times 30, which is 1,500, and then 50 times 35, which is 1,750. If Barbie ate somewhere between 1,500 and 1,750 calories, it would help her gain somewhere between a half to 1 pound a week. Now, to be honest, most people are going to use this because they want to lose weight. So you'd multiply your weight in kgs times 20 to 25. And then you come up with two answers, a lower end of the range and an upper end of the range. A good rule of thumb is that on the days when you exercise, you can eat the upper end of the range. And on the days when you don't exercise, aim for the lower end of the range. How do you lose a pound of fat in a week? This is a controversial approach to thinking about, and I would argue it oversimplifies the relationship between calories and weight. And you can go online or you're looking at resources, and there's some people who agree with this and some people who don't. I just want to introduce it to you because you hear about it sometimes in the lay media. There's some truth to it, although it doesn't hold entirely true. The notion is that a pound of fat contains approximately 3,500 calories of energy, because a calorie is just a unit of heat energy, right? And there are 7 days in a week. So, if you take the 3,500 calories a day and divide it by 7 days in a week, An extra 500 calories a day, if you can cut that out, so your baseline minus 500, you can lose about a pound a week. Okay, now most of the fad diets that you read about or see about in the news or online, they are based on the premise of calorie deficits. They tell you, hey, you used to eat 3,000 calories, now eat 2,500, and guess what? You're going to lose weight. Okay, they might put together some magical approach or some special food that they say helps you lose the weight, but the reality is you're running a calorie deficit. And if you're overweight and can cut your calories down by 500 calories from your baseline, not 500 calories per day, it's baseline minus 500 every day, okay, you're going to lose about a pound a week. Now, there's lots of other factors that go into weight loss. Of course, you'll eventually get to the point where you can't lose any more weight and so on and so forth. But this is a good premise for starting to think about how you might lose weight. It's by cutting back on the calories in your food and, of course, by increasing the amount of exercise that you do.